Question 15 says, rewrite each expression as an algebraic expression in x, show the triangle, and make sure to rationalize. So, kind of like on number 13, this is some angle here. So, you could rewrite this question as sine of theta, where theta is equal to tangent inverse of x. Now, it helps us to really have a fraction here. So any number we can put over 1. So I'm going to do that. And again, tangent is the opposite over the adjacent. So I can use this to make a triangle. So I'm not referring to the unit circle here. I'm just referring to a triangle which I'm making. So this will be x over 1. And then I want to use Pythagorean theorem to get the hypotenuse. So 1 squared plus x squared is equal to c squared. So if I take the square root of both sides, this will be 1 squared plus x squared, or that 1 squared is just 1, so it'll be 1 plus x squared. So this is 1 plus x squared. Okay, so we have our triangle. So we're basically done with the tangent part. Now I'm looking at the sine. So sine of theta is equal to the opposite over the hypotenuse. So the opposite is x. The hypotenuse is 1 plus x squared, the square root of that. And you'll notice these aren't nice numbers. We have variables here. So this is going to be an expression. And I want to multiply by 1 plus x squared, 1 plus x squared, the square root of those, because I'm rationalizing. And on top, that will leave me with x times square root of 1 plus x squared. On the bottom, when you have the square root of something times the square root of the same thing, you just get that same thing without a square root. So this is pretty messy, but this would be our final answer.